In the previous episode, we were able to create mesh around our Tekla solid geometry. And it worked both for the steel, both for the concrete, both for the curved elements. So at that point, I feel that we have something. So we will stick with this library for the tessellation, libtes.net, and I hope that it will survive the test of performance. But for that purpose, let's wait a little until we will have the whole flow of the data. Because at the very beginning, we started with the Tekla, then we were able to create the triangles around the geometry, and now let's try to create sample dotbim file, just to be able to upload it to some of the viewers and to see that, yeah, we are on the right track. So today we will try to create the exporter to the dotbim. And if we are talking about the exporter, then I think that it will not fit into the current directory. So let's create the new one. It will be named exporters. And of course, we will probably have only one exporter because this is the project which aims to the dotbim format. So let's add the dotbim. So here it is, the Nugget package, and let's install the newest version. Let's not think about what has changed between those versions. And yeah, now I see that that package, it serialized the data to the JSON. So probably it will need to take a look what version of the library is used inside of the Tekla structures, because that plugin will be run under the Tekla. So it will be running in the same app domain, and the Tekla itself will load their version of the Newtons of JSON library. So yeah, it can be a little tricky. Probably not for the JSON serialization because it's quite easy, but we will have to be not curious. We will need to pay attention to that aspect. But okay, let's start with some class to export. So what we will be doing, we will export to dotbim. So it will be the dotbim exporter, just like that. And yeah, let's stick with the naming, the typical naming, starting with the capital letter. So dotbim exporter, what it will get at the very beginning, what will be the input and what will be the output. And yeah, we want to create a dotbim file, and dotbim file or dotbim, yeah, let's see what is there. I will just provide some method, and I want to look into the dotbim namespace. So here we have the color, we have the element, the file, the mesh. So probably the file is something which aggregates the elements and the meshes. Let's see, that is the list of meshes, that is the list of elements. And the file, the name file is quite misleading because there is no the path. Okay, so the file is a container which holds the meshes and elements, and later we can save the file as the entity on your hard drive through some path. So okay, that's a little different concept of the file, but okay, it's not a problem. So the dotbim exporter, what it should do, create the file, not sure, but okay, let's start with that. Create file. Yeah, I rather would like to create dotbim, because create file, it highly points that you will be saving something on your hard drive. Okay, and to do that, what we will need. So here I will just try to use the dotbim, and then the file will be with us. Okay, and probably the file, it doesn't restrict anything, it has the empty constructor, yeah, because it is also used for the serialization, so it has to be like that. Okay, so what is needed for that particular creation? So that file, what is there? What we have? We have the elements. So okay, the elements, and it is the new list, and also we have the meshes, but probably they are initialized at the beginning. No, they are null. And we have also some info, and that's all what we have. The schema version. Not sure what schema should I pick. We will check it on the GitHub. So file info, let's just initialize a new dictionary, just like that. And there was one more thing, schema version. Not sure what should be here, so let's see what is in the samples. There were some samples, so let's go to the tips for the developer, and there will be schema version. It's one. Yeah, is it connected to the Nugget package version? It could be like that. From schema 1.0 there is a possibility to color. Okay, so 1.10 there are no releases. Maybe some list of changes, something. Just by scrolling, info, schema. Oh, there was something big stuff. What was that? Yeah, let's just pick that signature. I think that it should be here. And of course, yeah, we will create the completely empty dotbim file. And yeah, it can be serialized, but it will not have any data. So not good. But okay, where we finished our previous module, and it was about the solid tessellator. So yeah, here we were able to create the triangles. So we are getting the triangles from the solid, so the 3D representation. And yeah, we are missing the data, because if we look into that info, okay, what is the info? What is the info? Some general information about the project, about the authoring software, about, yeah, because there are two different type of infos. One probably is related to the element itself, so some property sets from the IFC word. But here example files, and let's see something. Test files from C# cubes. I hope that it will be not so big. So we have the schema version, we have the mesh, indices, elements, and the info is about just the author. Okay, so we at that point we don't need to think about too much about the info. The part which I want to think are those meshes and also those elements. Because okay, the element is okay, every element has exactly one mesh, and those meshes are represented here. So here we have just one mesh, and there is just one element, but it has type of brick, red cube, green cube, and blue cube. Okay, so there are three of them. Okay, here we have different vector, so it is located in a different place, and here, yeah, so they are just moved along some line, but they all use the same mesh. So okay, definitely we need somehow to provide here our list of the triangles, and later probably it will be connected also with the properties, but yeah, we need that list, and that list will create the mesh, the superposition of different triangles. And that is something which we currently miss, because we have just a read-only list of the triangles, so it's not very strongly typed. So definitely some new type is needed, because I don't want to just pass it here like that. I don't want to work on the I read only list for multiple elements, because it will be I read only list of I read only lists, and you get the point. It will be quite troublesome to grab your head around of such a combination. So we need a new entity which will hold the information about the triangles, but also information about the data which is connected to it, and also those rotations, vectors, quaternions, whatever is inside of the dotbim. So here we have the triangle. It's in the same file as another class, which has different purpose, so I don't like it. And here we have the triangle. Okay, so that triangle will be used for the mesh purpose, but the set of triangles, so the list of triangles, it should be added into some different stuff. And we already had a solid, which was the combination of faces. So here I want to create a new entity, and now I'm thinking about the name, because it will combine the data about the triangles and about the properties. So yeah, element data, quite a generic name, but yeah, let's try to think about something different. It should contain also the geometry and the metadata and some local coordination system. Those things are quite disconnected. So let's start with element data. Pretty generic, maybe not the best one, but okay. Let's provide something and build on top of that. And what we will need here, I will not get the triangles, but the list of element data. Elements, just like that. Okay, and what should be inside of the element data? Here I want to have the list of those triangles, so I will grab it here, and definitely I need that property, maybe just triangles, and just like that. We will also need here some type of properties, but I am not sure how in the dotbim element, mesh ID, vector, rotation, guide, type, color, face colors, info. Okay, so let's grab that very generic, but yeah, I don't want to have, it will be just the iDictionary, and it will be the info. Metadata, maybe a little different word, but okay, it will be like that. And I want to create the constructor for that, and that will be the placeholder for our element data. So here we will try to combine the triangles, the metadata, probably in the future also the vector and the rotation, because they will be needed. Okay, so we have the element data created somehow at some point of our code. I don't know exactly where, because now I am not thinking about that. I'm thinking here, because we wanted to create the dotbim based on some elements. And yeah, we need to transform this element data into the element, but mainly into the mesh. So I think that the mesh is a little more important, because here we need to create some quite strange, the list of coordinates for the mesh vertices and for the triangles. And those we are not working on some point representation, but for pure doubles. So we will be adding 1 point with 3 coordinates as 3 indices for that list. So it's quite a new concept for me, but yeah, let's think how we can do that. What we have added into. Okay, so it will be the sketch for dotbim exporter. Let's just stick with that, because probably we will very quickly go into different areas of development. So here I want to somehow create that list of meshes, and of course it is quite connected with the elements, because those elements will reuse that meshes, but let's just try to eat that elephant piece by piece. So what I want to do, I want to have internal method, some private one, which will create the mesh. Yeah, now from the high level create meshes, and it will accept that I read only list all the element data. Okay, here it is just like here. It's like that, and of course it should be done in a sequence, element by element. So here we will be iterating over all of our elements. So we need also this internal method, which will create the mesh only for one element. So here I will create the new one, and it will be create mesh and element data. Okay, so this is what I need. Okay, of course it could be one link sequence, but yeah, let's at that point not think too much about the details, but just have something working. So here I want to create the mesh, and for creating of the mesh, what is needed? What is here needed? Coordinates, indices, mesh ID. Oh, we need to specify the identifier for the mesh. And yeah, we don't have it here, because this is just data for the first element. So we could provide some iterator here. So just change it to the for loop, and let's try to do it like that. And here it will be the mesh ID. my first assumption. So that will be the mesh ID. We have it. Okay. What are the other? Coordinates and indices. Okay, get list of coordinates for the mesh vertices. Okay, I'm not sure how it should be set up. So let's see. What do we have here? It will be the first point, the second point. So for each triangle, yeah, but those triangles, they have the same point. They could have the same vertices because this is connected. So probably it is not the best idea just to populate with all of those triangles every time. It would be much better to check if that point was already added to that strange coordinates or not. So to get only the, how to name it, the distinct vertices. This is the correct word. And here, just looking, what is the biggest indices? 7. Okay. So here we have the 0 point, the first point, the second point, the third point, the fourth point, the 6th point, the 7th point, and what about the 8? It was not here. Once more. I don't see 8. And I started counting from the 0, so quite strange. But okay. Yeah, we could count 30 minus 7. Yeah, 7 points. Sorry, I have wrongly counted it. There is no error here. Okay, so how we can do that? We could use some. My first idea is to use the dictionary. Not sure this is the best, but the dictionary where the key will be the point and the value will be the actual position. Just the raw idea. So point dict, and it will be the dictionary of point. And yeah, I'm not sure how those points are compared. Comparable, nice, and I'm a little worried about the performance issue because we will be comparing every point with every. And there is the hash code, okay. Nice notice. Okay, so yeah, I'm trying to decrease the size of the output file just to not spoil and provide duplicated points. Is it true also for this sample? Probably it is for that small. I'm not sure how about other implementations, but yeah, the cost on our side will be that checking those points versus the dictionary could be quite heavy in terms of big meshes. But yeah, it's, I can be right or not without that and benchmark. It will be very hard to check. So I want to now check every point, every triangle, because we have the element data, we have the triangles. Okay, so at that point we don't need the whole element data, we just need the triangles. So here I will go a little deeper, because by the law of Demeter, sorry, we should not be coupled into some higher entities when we can be a little lower. So here it is, the triangles and the triangle and the triangle. It has 3 different points. So for every of them, I want to check if it is in that dictionary or not. So if it contains the triangle point 1, then I want to reuse that. So then, okay, var indice, it will be 0, just to provide something. And if we have it, then, I'm sorry, indice will be coming from that, okay? If it is not there, then of course we want to grab the new indice for the point. Okay, so we need some counter for all of those indices. Last point indice. Okay. Not sure about the details. It it definitely looks like something where I will make some error, because yeah, in DC it will be the last point in DC, and that is something how we will be able to get those indices. And why do we need them? Because for that mesh I want also to at some place provide the indices of those vertices and also the coordinates. So at the very beginning I want to create the map of those points to get their location, something like that. That's my first idea, but of course it's very hard to do that from the scratch. So let's add some test, and it will be the dotbim exporter. I want to create a new test here. Okay, and as always it will be the test class, the test method, and here what I want to test. I want to test this great dotbim for single phase. Let's name it like that, because I don't want to spend too much time on just getting the correct elements. So here I want to create the elements as a list of element data. It will be my first step. My system under test is what was the name of this class? dotbim exporter. Here it is, and our result, I want to get create dotbim. Okay, of course we need to populate those elements with something. So here I want to create the new element data with, let's start with just one triangle. Maybe not the best, maybe two triangles. It will be better, because then we will have 2 points which will be the same, so it will be a little easier. And it would be the best if we could just replicate that sample, but yeah, maybe it will be not so fast as I would like to have it. So let's create from the scratch. That's the typical response from the developer. I don't want to think about some existing solution. I will just create it from the scratch, because I'm always right. No, I'm just joking, but very often it's the true. So okay, here it is days, and what I want to do, I want to create here a new triangle, not the best. Okay, and new triangle, we need to provide 3 different points. So let's here just use the Tekla structures geometry, and I want to create the first point, which will be aligned from 0, 0, 0, and it will be going to, yeah, I need to draw it on some paper just to not, sorry that I am not presenting you what I am drawing, but I hope that you will trust me. So yeah, by the X we will go a little on the right, and then I want to go for 0, 5. The last point will be 0, 5, 0. So this is the planar mesh, and the second triangle, it will go from this, and the last point, it will be, just to get some rectangle, it will be at 10, 5, 0. Okay, this is something what I want to have as a test base, because yeah, it's just a set of 2 triangles where this point is used twice, here, here, and here, and here. So yeah, let's see how the create dotbim, especially in that create meshes, how it will work. So I'm not creating the empty list, I am now populating those elements, and let's see how it will go. There is some error. Okay, here is some error. So what we had that logic, and there are some other errors. Why? Not really. Let's rebuild all of the stuff, and let's see that, oh, we have quite a lot of different errors. Why? Oh, okay, we are using dotbim. Oh, I have loaded the reference to dotbim, and we have the collision of namespaces, because yeah, the dotbim is higher than the Tekla structures geometry. So to have it both, I will now do that stuff, And in every place it will be quite problematic, but in every place when I exactly know which vector I want, then I need to provide it like that. Okay, let's fix it. And we have the matrix transformation, we have that, and there are more places like that. So let's recompile, and we have the problem also where it's really clean solution and build. Okay, more places with such an error. Yep. Yeah, we could do such a trick that when we exactly know that we need the vector coming from the Tekla, then we will provide, but not for everything, because it will be quite time-consuming. Okay, where more? Why is it not? Okay, now it works. Okay, let's see our exporter. So I want to debug it. And let's see how at that point we will go. So we have a list of 2 triangles. Nice. Let's put it here. We have those points, and as I said, this and this, they are the same. This and this, they are the same. So they should be added only once, and that in this is mechanism it should be used. So we are checking if the first. Oh, we are only checking the 1 point. So it has to be done 3 times. So not the best, not how I would like to have it. So here maybe let's create some extra property named like points, which will just create some array which was created on the beginning. Sorry, I need to. Will you get the point what I want to do? Almost. So here I am initializing some private field, new point, and here I will populate the point. Yeah, let's go with those properties. Point 1, point 2, point 3. Okay, so now I am able to get those points. They are just read only, and yeah, that is not needed. So now in our dotbim exporter, I want here not to think only at the one element, but for all of them, all of the points. Sorry. So I will go with the loop, triangle, and points. So here will be the point, and yeah, we will try to grab that logic here. I'm pretty sure that that logic is wrong, but I am feeling that I'm a little overwhelmed with that. So I want to see it during the debugging just to get better understanding how it should work. So let's try. Okay, so we are checking the dictionary for the first point. Of course, it is not there. But I am checking that point, so it should be added with the indice 0. Okay, and we have it. So we have the first point with the indice 0. Sorry, the second point it also doesn't exist. So now it is added, the indice 1 and the second. Okay, for the first triangle, it was non-existent, so all of those points were added to the collection. But now we have the point which should be there. And yes, so okay, here we are not adding a new point, and the second point was also there, and only the last one was the new one. Okay, so we have it, as you can see. And okay, so we are able to create the point dictionary, which will provide us the distinct points, so those which can be purged from our set of points. Okay, not so bad. And now I think that we can use it to create the proper dotbim mesh. Okay, so we are one little step closer to our result. So what is really important from that for each loop is creating that dictionary of unique points, and when it will be in the dictionary or some other hash set, then we will be able to quite efficiently search for our points, to find their indices. And yeah, maybe it doesn't have to be the dictionary, because those numbers, they will be in a sequence starting from 0. So maybe it could be the list, but then comparing the list is not so efficient as with the dictionary, which has the key. So maybe some kind of a hash set, but then I'm not sure that we will stick too long with that representation of the point that coming from the Tekla structures geometry 3D. So, okay, let's not think too much about that exact place. What I want to change is that here I don't want to have that method which is for creating the dotbim mesh, but also here is doing something completely differently, which of course is needed for that mesh, but it doesn't fit, and it's quite a big chunk of for each loop. So let's start with some just changing, and okay, because yeah, that indice, I don't think that it is needed, because it's rather this one. And now let's change for the index. Okay, and that for each loop, it can be and it should be extracted to another method. So I will extract that method. I'm not sure about how it should be named, so maybe get unique points, something like that. And let's find unique points. Okay, just like that. So here I will have the point dictionary, and okay, now that's much better. That mesh, I'm not sure that it should be initialized here. I think that those anemic objects, they can be created on the fly, so we don't need it assigned to separate variable. But okay, here of course we have just the mesh, but we need two things more. We need the indices something something and coordinates something something. So let's think about the coordinates, because they sounds like more easy to grab. So here is the list of coordinates, and yeah, why again, why it's list? Oh, for the serialization purpose. But okay, but yeah, when we are creating that object, we exactly know how many elements it should be. So maybe just array, not list, because it will be dynamically allocating more memory when it will be increasing. So yeah, maybe, or yeah, there is this alternative list constructor when we are specifying the capacity. But okay, let's find out. So for the coordinates, I will just grab get coordinates method, and it should work on that internal point dictionary. So let's create that method. So we have some unique points, and I want here to get chords, and it will be the list of those doubles. But as I said, I will here provide the count of the dictionary, and I will return those chords. So now I can just loop for each over those points, and I want to add for that chord item key x. So we are working on those points, and we will add x, y, and z for each of those points, and it should work quite well, I think. Okay. So here we will have the coordinates, but we also need indices. Yeah, but maybe get mesh coordinates, it will be more informative. And here get mesh indices, and we need for that purpose two things. So we need those triangles, but also we need that mapping dictionary, because there the values are the indices of those points. So okay, here we need to provide the list, and do we know how many of them it will be? For every point it will have just one. Let's see. So I will get the indices and return those. Okay, and yeah, those are just integers. So okay, what we are dealing with that here, we want to specify that every triangle, so every triangle will have 3 points. So the number of those indices is not the count of the dictionary, it's not the count of the triangles, but it is count of the triangles multiplied by 3. That is what do we need. And then, oh, so the same goes here, sorry. Yeah. I wanted to save that list from increasing its capacity, but I made a mistake, because here we are not only dealing with the number of points, but we are storing those coordinates per se. Okay, sorry, that was my mistake. And here the loop will look a little differently, because we will work on the triangles. So for every triangle we need to find what is the indice of that particular edge, not edge, vertex. Okay, so here I want to add value coming from our mapping set of unique points, and it should work like that, I think. But okay, we will add that value coming from the dictionary, and it will point, okay, so which vertex is needed for that purpose. So we will have the mesh ID, coordinates, indices. Okay, we have the mesh. And why we have done it? Because here we wanted to create the meshes, nice. And here the elements are still missing, so we don't have the elements. So let's add a new method, create elements, and here it will be just the elements. And yeah, create elements from the elements. It's, yeah, we are working, so maybe here just renaming elements data, just like that. Here, okay, it's proposed to make it like that. Let's be it. It will not hurt us. Okay, so here elements, and that will be the list of element. Yeah, and just a comment. Now I see that getting those meshes and those, I think those methods, they could be extracted to a separate class, because yeah, we want in a dotbim exporter to grab all of them, but maybe not. Can it be done like that? Not really. So it would be some mesh creator, dotbim mesh creator, maybe like that. Let's just create a new method when it is the fresh dotbim mesh creator, mesh builder, yeah, something like that. So I will grab, yeah, that method, it has to be public, and now I will grab all of those previous one and push it here. Okay, here it is. I still have not changed it, so now we have that, and of course in that place we need to initialize that class in some way. Yeah, I'm usually doing it in that way, and let's just create some constructor for that purpose. So yeah, here it is. Okay, and just one that, maybe not create meshes, because yeah, it's just create. We are dealing with mesh creator, and the same will go with the elements creator. So it will be not the mesh but element creator. Of course we don't have such a class, but yeah, let's go with the same idea, because I think that it will in the long term help us. So now let's just make a space for that part, and here it will be the method create. Okay, and that will be the first dotbim element creator. Okay. Okay, here we were missing some, that one. Okay, so public class dotbim element creator, that was the name, and this is the first method which I want to use. Let's move it to separate file, and yeah, once more. Here it is, and what do we have here? Okay, of course I have not changed the name of that method, because it should be just create. Great, we have it. So now it's just time to populate that method. So what is the element? It has some identifier. Oh, nice. So we could streamline the identifier of the model object coming from the Tekla, but yeah, it sounds quite logically, I would say. And we need also the type of the element. Okay, should we stick with the IFC types? Probably yes. But okay, what do I want to do? I want just to make some element data, and here I want to create something from that. And of course we don't have such a method, so let's create that one. And if we will element data, sorry, it was my mistake. Can you change? Do you change? Can you change? No, you will create the new one. Okay. So here it is. And for that element, return new element. What is here? Oh, we can specify the color. Nice, but we have not touched it in the Tekla, so we are not getting the current representation. So now I will just try to get something. What is transparency? Yeah, it will be visible. Red. Let's make something RGB. Okay, let's make something pure red, just for the curiosity. This is the integer. Okay, with some checking. Nice. So we have the color. It should be queried. It should be red from Tekla, but okay. Now I don't want to think too much about that. Then face colors. Well, we can differentiate how those meshes, how those triangles will be colored. Maybe not this time, the identifier. Okay, here I will need to provide from the Tekla side that identifier coming from the model, but for now I will just dump it like that. Face colors no, info no, mesh ID, yeah, definitely it is something what we need, and also the vector and rotation. So the vector, yeah, we have not touched completely the coordinate system of those elements. So now every element will have different mesh, so it will lead to quite a big dotbim files. So in the future it will need to be changed to check are those elements the same, and probably it should be done on the Tekla level because the Tekla knows that they are the same or not. So we have the vector, but also we have the rotation, and the definition of the rotation is coming with some 4 values, quaternion. And I think that one it should be set to 1, the rest will be the 0, because I don't want to at that point to rotate that, because I am just heading into generation of some dotbim file just to see that okay, we have some file which is ready. And then we need the mesh ID. Yeah, now the question, what should be the mesh ID? And when we are dealing with those elements one by one, we are not thinking about multi-threading and using multiple processors, CPUs to that purpose, then I can assume it can hurt in the future, but okay, for now I will just convert that loop to for loop just to get the identifier, and I will pass that identifier just as a sample for the mesh ID, because we are doing it in the same order, both for the triangles and both for the elements. So it's just the assumption for now. Yeah, I'm a little afraid that in the future when we will be trying to speed up the process, then it will hurt us back. But okay, at that point we have that. So we were able to create a dotbim for a single phase, and it was here, and I think that it was the file. Yes, it was the file. So now I will try to create some file on my hard drive, just to see that it will work or it will not work. So here let's provide the path, and yeah, test.bim. So let's run the test to create that file, and it should be, oh sorry, it should be somewhere here, and we have something. Yeah, it's JSON file, so it's, yeah, just let's go straight to some viewer and see the result. We will see or not see. Yeah, it will be, what are those viewers? What is that? That is quite simple. Oh, and oh, ZioKit, the big one. Okay, let's stick with that. What is the most accessible at that time? So just test.bim, and we have the red rectangle. Nice. But of course, the geometry is not coming from Tekla, so let's now try to glue a little. So I want to get the list of the triangles from some existing Tekla element. So I will just grab a part of that. Here we had the triangles. So I will try, okay, so it was for the single face. Okay, it was quite a good one. But of course, we don't have the assertion at that point, and that will be just the dummy test. We should look back into that because now I'm just speed running to get some result, but it has to be done in a much better way. So here we have the triangles for some element coming from Tekla, and now I will just provide those triangles probably here. And there are some errors because yeah, I'm using the same names, so let's just create some shortcuts, and here it will be the dotbim, and it will be the dotbim, and now I am creating for this element in Tekla, and I don't remember what was that. So let's just create. Let's see until that file will change its date or size. And yeah, here it is. So the file is definitely bigger. Let's just drop it, and we have, oh, that was that curved wall. Okay, so we are able to create the dotbim for curved walls. Nice. So if we are in that mode that we want to try the possibilities, what it can do, then let's go with those stairs. I have checked it before. That's okay. Here are some concrete stairs generated by the Tekla. Quite small one. How it can be changed? I'm not sure. Step shapes, not really number of steps, maybe this one. So not 7, just give me 17. Whoa, now it's much better. And I think that this is done with some secondary parts. So that geometry is something what I would like to move into the dotbim. So I will now just copy the identifier and let's go with, not with that, but with that. Okay, so I will replace the previous identifier and recreate the dotbim file. So after a while, it will be, it is here. Great. Okay, so now let's drop it, and whoops, something is not wrong. Oh, yeah. That red is a little, I don't like it. So let's go with the mix. And does it support some transparency? Because then you will be able to display your rebars inside of elements in a different fashion. Yeah, it can. Great. Okay, quite impressive. The color magenta maybe not the best one, but okay, we have it. We have the possibility to export just a single element, but it finally lands in the dotbim file without those metadata, without a lot of stuff, but the pure geometry is there. So not so bad, I would say. And yeah, I think that for this material, that's all. I'm a little tired. So let's see on the next occasion, and I think that then I will try to move a little the code base just to be able to generate those dotbim files for multiple Tekla elements, and then we will see the performance. What is the hot path, and can we do anything in terms of speeding up the exporting from the Tekla to dotbim? But yeah, we will see how it will go. For today, thank you, and we will see next time.